Now this one is probably going to be a little harder to understand, and it's example 4 on page 43. I'm going to try to make sure that I talk about every kind of example that you're going to be responsible for, but I also have to take into account the things that you might have forgotten during, your excursions into mathematics. So one of the things that you might have forgotten is that there is a formula for distance. And the formula for distance is distance equals rate times time. So when you're looking at some of these problems, if they talk about distance, you're probably going to need that formula. I said earlier that you want to make sure that you understand everything that's there. So when we take a look at this one on page 43, let me pull the problem up so that you can see it. There are a couple of things in this problem that might be a little concerning to some of you. It says a space shuttle maneuvers so that it may capture an already orbiting satellite that is 6,000 kilometers ahead. If the satellite is moving at 27,000 kilometers per hour and the shuttle is moving at 29,500 kilometers per hour, how long will it take the shuttle to reach the satellite? And it said all digits shown are significant. Now, significant digits, if you've never had chemistry, you may not have heard anything about significant digits. Significant, of course, means important. So it's telling you that all these digits that you see here are important. And usually that refers to things that you might want to be rounding to. So when we look at some of these things here in the book, you're going to notice that the answer to this one they put as 2.400. And the reason that they have, 2.400 is the same thing as 2.4. And a lot of you are going to look at that and wonder why they added these two zeros at the end. Basically, whenever a problem has zeros at the end, if there are 3 of them at the end of the problem, you need to make sure that your answer has 3 of them. Now, I'm not so sure that most of the things that you guys are going into, you will need to know about those significant digits because you're going to be calibrating machinery and things like that. And you may or may not need the significant digits, but I wanted to point it out to you just because it's there. And you might actually want to go back and do some reading, maybe Google significant digits and take a look at that just so that you're up on that subject. If you take physics, you're going to talk about significant digits, but your book just kind of throws it in there in that example, and I just wanted to point that out to you. So when we do this problem, I'm probably just going to put 2.4 as my answer because 2.4 and 2.400 are the same number. And relative to time, it's not really going to matter which one you put as your answer. So I would take either one of those answers if you gave that to me in an answer. Okay, so when we're looking at this, it says the space shuttle maneuvers so that it may capture an already orbiting satellite that is 6,000 kilometers ahead. And when I draw a picture, like I've told you guys to do, is to draw a picture, I start drawing a picture and I look at it and I go, okay, so I've got this shuttle and I'm just going to draw a circle and I'm going to label it shuttle. And I've got a satellite that is 6,000 kilometers ahead. So I'm going to do this. I'm just going to draw a line and I'm going to say, well, that's 6,000 kilometers. And at the end of the 6,000, there's a satellite. So there's a very simple picture of what's happening. And since this is a distance, I know that somewhere I'm going to need to talk about those distances. And it even tells me, it says, the satellite is moving at 27,000 kilometers per hour. Now, a distance is something like kilometers or miles or feet or something like that. When they put this per hour in here, it's no longer a distance. It's a speed. It's a rate. So, you know, when you're thinking about miles per hour or something like that, that's a rate that you might have. And when we talk about these different formulas that we have the distance formula, which is rate times time. But if we needed to do something with the rate, we might have to get the r by itself, which means that we would have to divide by the time. So you need to take those things into consideration when you're looking at this. And the way that I do things that are distances, rates, times, those kinds of things, is instead of drawing so much of a picture, I will usually draw some kind of a chart just to get my bearings straight about these kinds of things. So I will look at it and I will go, okay, so distance, rate, time, and I know that I'm talking about a satellite and I'm talking about a shuttle. So I will give myself a little more information in the form of a chart and see if I can fill in the chart and see what's happening with that. Okay, so I know from my problem that it says how long will it take the shuttle to reach satellite. So it's asking about time. And I don't know anything about the time. All I know is that time in this formula is t. So when I'm looking at those two things, I'm just going to put a t in there and say for the satellite and for the shuttle, all I know is that in this formula they're t's. I don't know anything else about it. They did give me rates. They told me that the rate of the satellite was 27,000 kilometers per hour. And they told me that the rate of the shuttle was 29,500 kilometers per hour. So somehow I have to relate these two things. And when I go back and I look at my picture, I'm showing here that in my picture, my satellite is going 6,000 more. It's 6,000 more kilometers above the shuttle. It's higher up. It's gone farther. So basically what we're really saying is that if I took the whole distance that the satellite covered, and you know, let's say we had a starting point down here and they both started at the same place, you know, and then the satellite had traveled 6,000 more. If I took the distance that the satellite covered and I subtracted the distance that the shuttle covered, I'm going to have 6,000 because that's the difference in their distances. The distance between them is 6,000. So that's a difference between them. So if I look at my little drawing here and I could get the distance of the satellite and the distance of the shuttle, if I were to subtract those two, I would actually come up with the distance between the two that I have. So if I took the distance that the shuttle goes, because, you know, if the distance between this right here is 6,000 and the shuttle is going to have to go a little bit further because it's going to have to go what it's already gone and the 6,000 to catch up. So it's going to have to travel a little bit further because we're saying that the satellite is stopped at its distance here between the shuttle and the satellite, and we're trying to overtake it. We're going a little bit faster with the shuttle. It's, you know, trying to increase in the speed, so it's going to have to travel further than the satellite. So when we're looking at this and we're trying to figure out which one is bigger in order to do subtraction, you know, a difference is subtraction, but we've got to figure out which one gets subtracted from which one. Since the shuttle ends up having to go further because it's traveling faster to go to the same place, it is the bigger distance. So if I were looking at this and distance is rate times time, I have, for distance, I would have 27,000 t, because that's rate times time, and I would have 29,500 t. And if I took those and I subtracted them, and remember we always subtract the big number minus the smaller number, I would get a distance of 6,000. That's what I should get, right? So if I take my calculator and I do 29,500 minus 27,000, I'm going to get 2,500 times t, basic algebra. So if I divide by 2,500, I get t is 2.4. And that's hours because my original time was in hours. Now, if I had been asking about hours and my time had been in seconds, I might have to do a conversion. And there is a problem in your homework where you have to do a conversion. They give you some things in seconds, but your original time was in hours. And if you'll remember, 1 hour is 60 minutes. So if I was going to have to go to seconds, I would say 60 times 60, and that would give me 3,600 seconds for an hour. So if I needed to make a conversion, that's what I would do. But in this problem, everything's the same, so I don't have to worry about it. So it would take me 2.4 hours to go that distance to catch up with that satellite that I need to. And in this one, and it's just a suggestion, I did a drawing to help me figure out what was going on. And then I did a chart because I had a formula I had to deal with. And sometimes that's the best way to look at some of this stuff, is to draw a chart and do a drawing just to help you figure out what's going on.